To understand and learn how to use the earned value technique, I will work with the made-up example project, a very simple project. A project manager has been asked to install 100 posts. The PM went through detailed planning and created the cost and schedule baseline. Now forget the contingency and management reserve, weekday or weekend details. Just take it as a simple project with those considerations. So the project management plan says that it will take 100 days to install 100 posts at the rate of 1 post per day, and it will take $1 to install each post. Only one post can be installed at a time, so there is no parallel work. Now let us extract some data. What is the total expected spend on this project? Well, it is $1 per post, so for 100 posts, it will be $100. That is the cost baseline. In earned value terms, it is represented by the term BAC, or budget at completion, or the total planned cost for the project. So BAC equals 100. Now say the project manager started working on the project and 30 days have passed. At the end of the 30th day, the project manager was asked to submit a status report. According to the schedule baseline, how many posts should have been installed by the end of the 30th day? 30 posts. So according to the cost baseline, how much money should have been spent to install 30 posts? $30. This is called PV, or planned value. The money that should have been spent as per the cost baseline by the status date. So PV equals 30. Now the project manager counted all the posts that have been installed and found that 35 posts have actually been installed in 30 days. So what is the value of 35 posts? $35, because each post is worth $1 as per cost baseline. This is called EV, or earned value, or value of the work actually completed up to the status date. So EV equals 35. Next, the project manager added up the receipts and vouchers for all the expenses that were incurred and found that total actual spend was $40. This is called AC, or actual cost, or the total money spent till the status date. So AC equals 40. Now with these last three pieces of data, the project manager can perform variance analysis. There are 4 formulas that are used. 2 are variances and 2 are indices. The variances are called CV, or cost variance, and SV, or schedule variance. The indices are CPI, or cost performance index, and SPI, or schedule performance index. Here is a trick to easily remember the formulas for these 4 terms. Write CV, SV, CPI, and SPI. Then put the equal sign in front of all 4. Next, write EV for all 4. Then the variances are differences, so put down minus sign after EV for both variances. And indices are ratios, so put down division sign after EV for both indices. Now the last term for all 4. CV is cost variance, which is the difference between the value of the work completed and how much was actually spent to complete it. So the term is AC. SV is the schedule variance, which is the difference between the value of the work completed until the status date and what should have been completed as per plan. So the term is PV. In the same way, CPI will take the same last form as CV. So the term is AC, and SPI will take the last term same as SV. So it is PV. These are the 4 formulas needed to establish the current status. So for the post-installation project, CV equals EV minus AC, 35 minus 40, minus 5. PV equals EV minus PV, or 35 minus 30 gives us plus 5. CPI EV divided by AC, or 35 divided by 40 gives us 0.87. And SPI EV divided by PV, or 35 divided by 30 gives us 1.17. So for variances, negative bad, positive good. So CV shows that there is cost overrun. The project is spending more than the plan. And SV shows project is ahead of schedule, going faster than planned. For indices, ideally they should be 1 if the project is going as per the original plan. Less than 1 is bad, greater than 1 is good. So in our example, CPI shows cost overrun, which is bad, and SPI shows ahead of schedule, which is good. This is how earned value can be used to establish the current status of the project.